Okay, welcome to Q-munity Tutor TpVid section 6, the physical operations of a quantum computer. And I'll be talking about the trapped ion situation where we need to isolate the ion, and the ion is just a positively charged atom. So let's have a look at how all of that works. And what we tend to use is a calcium atom, which has got 20 protons and 20 electrons. So it balances itself out. It's what we call a neutral atom. But amazingly, with a directed laser light, we can, if you just look at the outer orbital, where there are 2 electrons, we can knock one off, leaving the calcium ion with a positive charge and 1 electron in the outer orbital, which we can manipulate. So what we want is to isolate that ion in space, and we do that because remember now that ion is positively charged. So we have 2 electrodes either side of it, and these are charged positive, and that will hold the ion in place, because now that we have it as a charged particle, we can use other charged particles to maintain the equilibrium. But let me give you a more detailed analysis of how it's all done. Okay, so let's have a look at how we isolate the ion. And what we've done, remember, is we've had the nucleus here, and we have certain electrons. And what we've done is we've managed to shoot one off by sending a laser, so that we have one on the outer final orbital. So what we now can do, this ion now has a positive charge. And so, as you know, like charges repel, opposite charges attract. So what we can do is apply charges to keep the ion stable in space. And we have these things called endcap electrodes. And they give out a positive charge. And what that means is that the ion has nowhere to go, but it can actually go up or down, so it still can escape. So we need more electrodes. And what we do is we use what we call blade electrodes. And we can't make them all positive, because if we do, it becomes very unstable and the ion will escape. So what we do is make a couple of these blade electrodes, positive and negative. And then what we keep doing is flipping from positive to negative. And this has the stabilizing effect of keeping this ion suspended in space so that it's not touching anything, and with microwave pulses it can then be manipulated to its superposition, mathematically representing a qubit. Thank you very much, and I look forward to seeing you in the next session. Thank you.